So starting off with a review of our exponent properties. Okay, with our exponent properties, if we type 2 to the 5th into the calculator, what it's doing is 2 times 2 times 2 times 2 times 2. So it's an exponent tells us how many times that we're multiplying by. So I know that 2 times 2 is 4. 2 times 2 is 4, and then we'll have another times 2. So I know that, let's see, I can break this down further. 4 times 2 is 8, and 4 times 8, so this would be 32. Then, number 2, if I had done 2 squared, I know that's 4. If I had done 2 to the power of 3, okay, so I know 2 squared is 4 because 2 times 2 is 4. 2 to the power of 3 would be 2 times 2 times 2. That would be 4 times 2, which is 8. And 4 times 8 is 32. Next one, number 3, we have 2 times 3 to the power of 2. So 2 times 3 is 6. And 6 to the power of 2 would be 6 times 6, which is equal to 36. Then we have 2 to the power of 2. So 2 times 2 is 4. Times 3 to the power of 2, so 3 squared is 9. Sorry about that. And 4 times 9 is 36. Next, we have 2 to the power of 6. Now, I figured out that 2 to the power of 5th was 32. So 2 to the power of 6 will just be 2 to the power of 5 times another 2. Because remember, an exponent is just how many times we're multiplying. If I've already multiplied 2 out 5 times, this is just me multiplying it a 6th time. So we said 2 to the 5th was 32. And 32 times 2 would be 64. Then number 6, we have 2 squared to the power of 3. Well, I know that 2 squared is 4. And then 4 to the power of 3 would be 4 times 4 times 4. I know that 4 times 4 is 16 times another 4 would give me 64. So the connection of doing these specific 6 problems is, notice how we got the same answer a few different times. Okay, so the connection between numbers 1 and number 2, you can, if you're multiplying the bases, so in this case we had 2 squared times 2 to the 3rd, that's the same thing as adding those exponents together, so 2 plus 3 would give us 2 to the 5th, because we got the same answer either way. We got 32 as 2 to the 5th, or 2 squared times 2 cubed. The connection between number 3 and number 4. If you have an exponent on the outside of the parentheses, you can kind of give it to every term on the inside, but that's only true when you have multiplication right here on the term. Okay, so if it was an addition sign, we would not be allowed to do it. Notice how there's also a multiplication sign here. It does not carry over to addition and subtraction. Okay, so what we learned is that if we have 2 times 3 to the power of 2, that's the same as 2 squared times 3 squared. Again, that only works when you have the terms inside the parentheses being either multiplied or divided. Addition or subtraction does not work for this property. Then for number 5 and number 6, that connection. If you have an exponent on the outside and an exponent on the inside of the parentheses, you can just multiply those together. So then our last one we have, let's see, 2 squared to the power of 3. So if I just multiplied 2 times 3, it would get me 2 to the 6th, which we got 64 either way. So if you have an exponent inside and outside the parentheses, you can multiply them together and simplify that way instead. Okay, so these are all properties that should have been covered in Algebra 1, but we are going to be reviewing it again today. Okay, so simplifying, you'll notice we have some letters thrown in there now. So You can't depend on your calculator at that point then. Okay, so for number 7, we just want to combine like terms. So in this case, the 3 and the 4 multiplied to become 12. And then we have, so we just did 3 times 4, and we're now going to do it times x to the 5th. Now we learned in this last problem that if we are multiplying like bases, we can just add them together. Or sorry, multiplying like bases of the exponents, we can just add the exponents. So there's really a 1 on that x, and I know that 1 plus 5 is 6. So this would become 12x to the power of 6. For number 8, we want to give this exponent to everything inside because there is a multiplication on these terms. It would not work if it was addition or subtraction. So we have 2 to the power of 3 and then times a squared. Now how do we combine these two exponents? Well, we have one exponent inside and outside the parentheses, so we need to multiply. So we'll have 2 to the power of 3 times a to the power of 6. Now I can simplify that. 2 to the power of 3 is 8, because 2 times 2 is 4, times 2 is 8. So our final answer is 8a to the power of 6. For number 9, I want to give this exponent of 2, because again, these two, the a and the b are being multiplied, so we can do that. So we'll have a squared times b, and it will be to the 4 times 2, because of the exponent inside and outside the parentheses, which is equal to a squared times b to the power of 8. For number 10, the only thing that's changing here is we have a letter as an exponent. That doesn't change our property. So we'll multiply n times 2, which is just going to be equal to 2n. Okay, so I like the problems with the letters and the variables because you can't do them in your calculator, if I'm being honest with you. So you need to know your exponent rules to simplify. Okay, next few problems. Feel free to pause the video and try these on your own at any point. Okay, so for number 11, we're going to combine what we can. We have 2 times a negative 5 is a negative 10. Then we have x squared times x to the 4th, and I know that we add those, so 2 plus 4 will be 6. And then we have y to the 3rd times y squared. So we'll have 3 plus 2. So this simplifies to be a negative 10x to the power of 6, y to the power of 5. Number 12. So when we multiply, we add the exponents. So when we divide, we're going to subtract. So I'm going to say it again. When we multiply the bases, we add the exponents. When we divide like bases, we subtract the exponents. So this will just be x to the power of 10 minus 7, or x to the power of 3. Okay, number 13. There is a negative sign grouping this 5. So this is really a negative 1 times x to the 3rd to the power of 5. So I want to give the power of 5 to both of those terms. So we have negative 1 to the power of 5 times x to the 3rd to the power of 5. So we multiply those. Negative 1 to the power of 5. Well, negative 1 times negative 1 is a positive 1. Times another negative 1 is a negative 1. Times a negative 1 becomes a positive 1. Times a negative 1 becomes a negative 1. So if you raise negative 1 to an even power, it becomes positive. If you ever raise it to an odd power, it stays negative. And that will be negative 1x to the 3 times 5 would be 15. We do not need to write the negative 1 times x to the 15th, so we'll take that away and just write it as a negative x to the power of 15. Okay, number 14. Again, we want to, well, I guess we have a negative 5. If you want to see it as like a negative 5 or negative 1 times 5, you'll get the same answer. So for this one, we have our first negative exponent. So for a negative exponent, if you have x to the power of negative 2, it creates a fraction. So that's equal to 1 over x to the positive 2 power. And when you flip that to the other side of the fraction, it becomes a positive exponent. So if it is in the numerator, you can put it in the denominator and it becomes positive. If it's already in the denominator, you can move it to the numerator and it becomes positive. So I'm going to work from the inside out. So we'll have negative 5 to the negative 1 power. So that would be the same as 1 over negative 5 to the positive 1 power, which something to the positive 1 power, we don't need positive 1 power. So that goes away. Now this is all raised to the negative 2 power. So that is going to flip again to make the 2 positive. And then negative 5 squared is equal to 25. There's a few ways you could have done that problem. That's the beauty with these exponent rules. You can get really creative with them. You also could have just multiplied negative 1 times negative 2. And that would have been a positive 2. And negative 5 squared would be a positive 25. Either way. For number 15, though, this is why I wanted to talk about that negative exponents. We have negative 2/3 to the power of negative 2. The negative sign on the exponent causes this fraction to flip. So it's now a negative 3/2 power, or sorry, negative 3/2 to the power of 2. So now the exponent has become positive because I flipped the fraction. Then I want to make sure this exponent gets to both of my terms on the inside because we are dividing these. We can do that. If it was subtraction or addition, we would not be allowed to. So we have negative 3 squared over 2 squared. Negative 3 squared is 9. 2 squared is 4. And our last one, the x is negative, so he's unhappy. We want to move him down. The y to the negative 2 power is negative. He's unhappy where he's at, so we're going to move him up. So the 3 is perfectly content where it's at, so it's going to stay up there. So we'll now have y to the positive 2 power in the numerator and x to the positive 1 power in the denominator. You do not have to write to the power of positive 1. You do have to write to the power of negative 1. So that would be your final answer. So a new property that we learned here was with our negative exponents, it flips the fraction in either direction. So it either puts a term in the denominator or it brings the term from the denominator into the numerator, depending on which way wherever the negative exponent is.